Thanks for showing up in such great numbers. That made showering all worthwhile this morning. I'm obviously not from here. I'm from London, England, so I'm confused by this yellow thing outside that you have in the sky. That is also bad for redheads, so I'm just like, I'm staying in here and be with you, so I'm safe and sound. This is not me confused by a toilet. This is me actually at the Harry Potter studios, and that's the pensieve of Dumbledore, you know, when he wants to forget something and then remember it again, the thing that comes from there. And I thought it was pretty cool to take a picture there. And I also was on the plane and didn't have any access to the internet, so I just randomly put pictures in there I had on my hard drive. Because I coach people on public speaking, I do a lot of public speaking, and your slide deck should always be your wallpaper, not your presentation. There's nothing worse than people read out their bullet points to you, which is kind of ironic because I have a few bullet points to read out, but you will see that later. I want to talk about JavaScript, and I've been doing JavaScript for a long, long time. I wrote the first Ajax book in 2006 because my publisher said Ajax is awesome, and let's put that in there as well. So explain what a variable is and cover Ajax in the same book, no pressure. So it was very interesting. I read the book so many times while writing it. At the end of it, I just couldn't, I wanted to rewrite it. And that's the problem with JavaScript. It's moving so fast. We want to do things all the time newly. And it can be quite frustrating right now to try to keep up. When I open my RSS reader in the morning, yes, I'm one of the old people that uses RSS readers, I find like 6,000 new things in JavaScript, and I feel like, oh my god, I'm falling behind, and I'm old, and I will die in a ditch, and it will not be nice anymore. And a lot of people feel that. We innovate and we frustrate ourselves at the same time, and that's not the idea of technology, I think, and not the idea of community. So JavaScript is a lot of things. It's an incredible versatile language. It's like, you know, there's no type safety. You know, a variable can be a number, an integer, a string, a cat, a dog, an elephant, whatever you want to make it, and you can turn them from elephant into a duck and to a number as well, which confuses a lot of developers. It's available web-wide and across many platforms. That's the really cool thing as well. It's basically a thing you can rely to be available to a degree. And I'm beeping here, so sorry about that. It's toolset independent. That's what I loved about JavaScript the first thing when I started it. I started with like edit.com on a Windows 3.11 machine, and then later on like text edit, and that's all I needed. It wasn't like, oh, download Borland C++ builder for $20,000 and then you can start becoming a programmer, and you're like, what? So you can build it with any tool set, and it's quite funny how every month we say like, you have to have this editor or you're not professional and you're not perfect. Yeah, I used every editor on this planet after a while. I'm now using Sublime Text. I'm thinking about using Visual Studio Code just to test it out and want more. And yeah, I use VI whenever I'm on a server, and it's quite fun that you can jump between those two. And it's very forgiving and inviting. It's not a language that tells you like, oh, everything is wrong that you're doing. It's like you can make terrible, terrible things in it, but you can also write really beautiful code in it. It's a bit like PHP in that way. You can use JavaScript for browsers on the web. That's the biggest use case. That's what it was made for. But we shifted around a lot. We put it on the server now with Node.js, and there was LiveScript in 1997 as well by Netscape. That was not fun. You can use it in applications. Many people don't know that, for example, you could script Illustrator in JavaScript. And I've written a lot of scripts for people and for designers in my company to use JavaScript inside Illustrator. You can access services. You can have like JSON objects from data services, for example. You have JSON as a data format as well, and you have it on hardware like the Tessel and all kind of like little IoT devices running JavaScript now as well. And you can put it on your dog or your cat or whatever you want to do. I mean, like every JS conf you have like, oh, I have a nodecopter and I've got a fridge, and people put it on everything. It's like the new Linux kernel that you put on everything. It's amazing. There's actually a Linux kernel in JavaScript as well, because we can. And this flexibility of JavaScript makes all of that possible. It's a very versatile language that changes itself to the environment. So best coding practices in a Node.js server is probably not the best coding practice on a front end. But people keep telling us this is one thing and we all have to be like modules and class-driven and whatever. JavaScript is in super high demand. You can find that out when you do Google Trends and you look for undefined is not a function. Then you realize that in 2014 a lot of people went from Java and other languages into JavaScript and basically like, oh god, what am I doing here? This is so weird. We're going full speed on innovation. There's componentized web, extensible manifesto, WebGL, WebAssembly, PostCSS, progressive apps. There's really cool stuff. Read all of that up. There will be a test later. And JavaScript technically doesn't exist. It's a language that has been done in 10 days in caffeine and probably other substances infueled rage by this person, Brendan Ike. And this is when I stole his name tag at the last conference. And for 10 days he built a language from scratch because he had to. It was this completely random time frame. And he basically built this thing, and we think it's like a scientific thing. I see it more as like a Frankenstein thing, like thunder and claps and like electricity fizzing. I think that's how it happened, because there's a lot of weird things in that language. But I like that. I mean, I'm a German living in England. I like weird languages. So the problem is that he called it JavaScript, because Java, you might not think, but that back then Java was cool. And he thought it was a good thing to sell that language by calling it JavaScript. But the thing is that Java to JavaScript is the same as like ham is to hamster. It can be done, but it's not a good idea. And it's not necessarily the most beautiful thing to think of. Or car to carpet, but it's always fascinating when you get job descriptions like, yeah, we need a JavaScript developer who has like 6 years of Struts experience, and you're like, you want a Java developer, you really do. And my favorite is when you get job descriptions that like half-a-year-old technology, 7 years experience in that one, please. And you're like, well. So it's been a bumpy ride. JavaScript does not exist. The standard, it's called ECMAScript, and the TC93, for some reason it's called that, is the standards body of this. And in 1997 we had ECMAScript 1, and that was basically the first iteration of it. Then we had ECMAScript 2, ECMAScript 3, then we got confused, and ECMAScript 4 got abandoned between 2005 and 2006. Then everybody argued where the language should be going, and then we had ES Harmony, because we found Harmony again. In between Adobe created all kind of script inside Flash, like ActionScript. Microsoft had their own language scripts. Everybody came up with their own language scripts, and now we have ECMAScript 5 in 2009. And that lasted for a long time, and now in 2015 we finally have ECMAScript 6. Now, ECMAScript 6 is 5 years since the ECMAScript 5 ratification, and there's some significant changes in the last 15 years, and for the first time we put these changes into the language. People always wanted to turn JavaScript into their favorite language. Like, first it was Java, then it was Ruby, then it was Python, then it was Haskell, then it was Lua, then it was whatever people use nowadays. Julia is a new cool thing as well. And we never said that, or the standards body never said like, well, it's a different language, we don't want to have these things. But now we put a few things in there because our environment changed. JavaScript is not only used in the browser anymore, and with IoT coming our way and like low-end devices, we have to have a language that is more strict, that actually gives us a type safety, that uses up less memory. Because a flexibility of a language means also it's hard on the machine and it's hard on the RAM, because it actually tries to guess a lot of stuff for you. And I never liked much languages guessing stuff for me. That said, it's backwards compatible. So ES6 browsers will also run ES5 code, and there's no problem with that. Like, you can write your JavaScript, like the rollover functions will still work, but you should not use them any longer. It's ratified in June 2015, and there's basically now a standard for that. But let's not go overboard with this first of all, because if you remember, XHTML was considered a bad idea, because it was one. The idea of XHTML was that we put XML on the web and we make the web incredibly strict. So any single error that you do in your HTML, or the ad provider that you used, or your content management system, or what you see is what you get editor that you used, would end up in this yellow screen of death and telling you like, sorry, this is broken, you cannot get to this website. Much like a PHP script having an error will not render the page. I kind of like it, because it means like we know when something is very, very broken, but on the other hand, our end users get punished for our mistakes, and that should not be the case, because the web is there for people, not for us. So that's why in HTML5 we said like, okay, let's make a parser that is much more forgiving. So when you don't close a p tag, it closes the p tag for you. If you nest things wrongly, it puts the thing outside the other thing. If you don't encode something, it tries to guess what it is, and it gives you funny glyphs and stuff like that. But it means the end users will always have a working website. They will always have something that is usable to them, not necessarily beautiful, but usable. Because HTML and CSS are both built with fault tolerance inbuilt in them. So when a browser encounters an HTML element it doesn't know, it just, okay, whatever, I just show you the content of it. When a CSS parser sees a CSS declaration it doesn't know, it, I'm going to the next line, that's fine. If a JavaScript has an error in it, it says, oh my god, the house is on fire and I'm going to die and I'm not doing anything anymore, and that's the rest of the computation of that JavaScript. So it's kind of weird that by that we overuse JavaScript continuously right now. This is nasa.gov right now. And it gives you the idea of the expanse of space by showing you this black screen for about 12 seconds before it actually shows you the first page. And then it shows you some spinners because you didn't wait long enough. And then it shows you the page and it's finally finished at 14.8 seconds. The reason why that is that it has 3 megabytes of blocking scripting before the first page appears. So they put Ember and jQuery into one JavaScript file and didn't minimize it and didn't put a defer on it and just put it in the header of the page. And before that's loaded, the browser doesn't do anything else. And this is kind of breaking the web like XHTML has done as well. Because one single JavaScript error if you rely on complete rendering of your page and all you get is this. Which is kind of pretty, but also very much showing like, hey, user, I hate you. Because I don't want spinners on the web, I want content on the web, I want images on the web, I want video on the web, I want 3D, I want web VR on the web, I want cool shit on the web, but I don't want spinners and I don't want the thing break when there's one single error. But we do that in JavaScript all the time. It's partly because of the JavaScript learning process that we had over the years. It's always been interesting. The first thing we did is use view source to see what others are doing. Then we copy and paste the bits that look like they're responsible to do some things. Then we change some numbers around, and then we run into errors, and then we blame Internet Explorer. That was back in the days, of course, but nowadays we're much more professional. Nowadays the process is we search for a solution on Stack Overflow, we copy and paste the bits that look like they're responsible for some things, we change some numbers around, we run into errors, we blame JavaScript for being a terrible, not a real language, and for good measure we blame Internet Explorer. I call that the full stack overflow development flow. Where we just don't know what we're doing, but we just copy and paste it in there and put more and more in, and the more it is, probably better, you know, like another framework, yay. If you think JavaScript, think of escalators. Mitch Hedberg made it as a joke, like an escalator can never break, which is kind of ironic because the escalator here is blocked right now. But the idea of an escalator is that when it breaks, it becomes a set of stairs. The idea of a lift or an elevator, as you call it, when that one breaks, it's a room where you're with people that you don't want to be in. So an escalator will always be a possible thing to go to the other floor. So should your JavaScript solutions. You should build on something that works and make it prettier and better with JavaScript. And that way you have full control over the experience of the user, and the users will never get something broken. We always want to use JavaScript for everything because we want to control the user. Wrong. This is never going to happen on the web, and I'm going to give a keynote about that later. I almost got the wrong slide deck here. Embracing ES6 promotes JavaScript from a hack to a language to build large products with, because we have a more stricter language now, and we have more a pattern approach to development rather than just writing random things in there. So JavaScript is not the duct tape of the web any longer, because we loved that for years and years, and we put too much duct tape on the web. ES6 comes with so much goodness, it has to be fattening if you think about it. Most of these things have different audiences. So you got the syntactic sugar. So for example, arrow functions, which means you don't have to use anonymous functions anymore. You even don't have to use a function name anymore if you just want to do a few braces things and the arrow function in between and make it completely unreadable, but yay, less characters. The best thing about the arrow function is that it solves the this problem, because the this scope always becomes the this of the parent, not the this of the function itself. So that means that C++ developers and Java developers don't hate you any longer, which is a good thing. We have got template strings, which is now template fragments. I think I have to change that. That is really cool. That's like PHP strings. So you have like, you can put $, and curly braces in there, and every expression inside that string gets replaced with the JavaScript that runs in that string. It's a backtick instead of a normal quote, and it also has if you put a word in front of it, that becomes a function that gets called, that parses that string before it gets printed out. So it's basically client-side templating directly in the language right now. Also a great way to get some XSS errors into your page if you don't actually make sure that the JavaScript that comes in gets properly sanitized. But we haven't done that yet, sadly enough, happily enough. REST, spread, and default is pretty cool as well. We got default parameters now, so you can say function A equals 1, B equals 2, and so on and so forth. So you don't have to do the A, if A is undefined, then do this double braces kind of preset kind of thing. It's not fun. But it also shows that when you write your code, it shows what you expect, which is pretty cool. The spread and default is rest and spread means you have a not a defined amount of parameters in the function, but you can send an array in, and you don't have to use the arguments array anymore to read that one out and then find the thing that you wanted to have. It looks really nice, and it actually makes for very scalable functionality, but I find it rather hard to read by now. I probably have to get used to it, but I find it like every time I hire JavaScript developers, the more parameters you had in your function, the less likely I would hire you. Because it's like, then the order is important, and then you really don't know what's going on. I'd rather have you to have a JSON object with a name parameter, and then I know what you want from me and what you put into that function. So it's kind of again shortening. A lot of the shortening that we do right now is like, oh, it's much more easier to read right now. Yeah, if you know it, but if you're an old fart like me and you come from the old JavaScript, then kind of weird at times. Especially the amount of times I try to debug JavaScript with arrow functions in it as PHP is quite amazing, but you get used to that sooner or later, I guess. For scalable applications, we've got let's, const, and block scope binding. So with that, the variable will be to that block rather than to the parent, and you can with const you can never override them. So they get memory allocated to them, but they get never overwritten anymore, which means it uses much less RAM than JavaScript does when you could reallocate the const all the time. It's funny how people say like use a const and then like why can't I reset it? And you're like. It's a bit like in CSS when people are like, why can't I use two IDs in the page? And you're like, what does ID mean? Identifier. How do you identify two things with the same name? Oh wait, yeah, that's okay. Promises is absolutely amazing, of course. It's the new thing that every single API that comes out now has promises rather than callback hell and like function event handling. Classes is what everybody wanted, and now we have it in JavaScript. Typed arrays is something that fell out of WebGL, strangely enough. So you have like arrays that are much faster because they run on the video hardware, and they also have been selected. So the array doesn't get iterated every single time you go through it. That is also part of the JavaScript engine, weirdly enough. In the Chakra engine, we did a lot of optimization for for loops because people write terrible for loops. No, you don't need to read the length of the array on every iteration, but every copy and paste example on Stack Overflow shows it that. That's a good thing. And for library builders, we got map, set, and weak map, which is like you don't use arrays, but you have proper mapping, and it's much easier to use that one. Proto, proxy, symbols, subclassable built-ins, and so on and so forth. The support is kind of encouraging. This is a great website to go to, Kangax, github.com, github.io, compat table ES6. And that one shows all the different environments that run ES6 and how much their support is. Now, support is always a thing, like when you go to html5test.com and like, which is the best browser that has the most HTML5 support? 90% of those things you will never use. What you really want to have is like a good solid support for the things that are necessary. The Maxton browser is always the one that wins html5test.com because it uses every rendering engine on the planet inside that browser. But you never know which one is in use right now. So for debugging, it's actually more or less like a choose your own adventure game rather than finding out what the browser is doing. So let's look at some numbers because people love numbers. Microsoft Edge 13 is 80% support of ES6 features, Firefox is 71%, Chrome and Opera is 63%, Safari is 54%, and on mobile we got Android 29% and iOS 9 54%, and that makes me very, very happy. Because at every conference I go right now, people complain about Safari falling behind, which is, yeah, it does. And with ES6, it's the first time that iOS says like, okay, we're on board as well. We need ES6 for our own platform. We now made the automator scripts, for example, in El Capitan JavaScript as well. We need this functionality. Whereas in CSS, there's always the argumentation like, we get our own stuff. Why don't you use ours? Because it's patented. Yeah, okay, but we have our own stuff. Why don't you use ours? Anyways, the problem for non-supporting browsers, ES6 features are syntax errors. If you put a fat arrow and you run it in Internet Explorer 8, it says like, I don't want to do this. This is weird. This is something I don't know. So there's several ways out of this. One of them is transpiling to ES5. Babel.js.io is a transpiler. So you give it code and it converts it to ES5. And it runs on the server, it runs on the client, it runs in like build scripts. You can use it for whatever. It converts the ES6 into older versions on the server or the client, so you can get ES3 as well if you want to support like Netscape 4 or something like that. Why, I don't know, but you might want to. It's in use by Facebook and many others, and Facebook just hired the guy who wrote Babel.js, and I hope he is happy and they feed him and they keep him doing lots of open source stuff, but they're actually good at that, so I'm quite sure they will. And it's also used in editors and tool chains. So in editors, it's really sweet that you can write ES6 and get all the beautiful thing of pattern development and the shorter syntax, but you know that your code will run because it under the hood gets converted into something else. So you can see in the REPL that is live on the Babel.js website that you can write your code on the left-hand side, and on the right-hand side it turns it into JavaScript that you should have written, but you don't want to because it's super complex at times. The problems with transpiling is that you have an extra step between writing code and running it in the browser. What I loved about JavaScript is I basically wrote it, changed it, reloaded the browser, hey, it's done. Now I need to go through my transpiler script and see something happening in my terminal, and I'm okay with that, but somebody who's just starting as web developers probably will be confused by that. And it's just an extra step to, let's say, people like, you want to write JavaScript? Well, you got to have a MacBook Pro, and you got to install Ruby, and you got to go to the terminal and do this, and it just feels kind of odd. We don't run or debug the code we write. That's the other problem as well. What's happening in the browser in the end is not the code that we've written. So that is terrible if you think about it, because performance in the browser is our most important thing, and we don't even own the code that's going out in the browser. So if there's performance issues with it, we don't know what's going on. We hope that the transpiler creates efficient code, but we don't know. There might be things that in one browser is inefficient and in another browser is more efficient, and if you've written it by hand, you would know this, but if the transpiler just creates this massive amount of code, you have a problem. And we create a lot of code. That's the same with every pre-compilation, like Sass, less in CSS as well. The amount of people like, oh, it's 15 lines of Jade, and it's like, okay, now it's like a page of 6 megabytes because we never saw that. We never saw the final product. We saw the code that we wrote to create it. And browsers that support ES6 will never get any, and that's the real problem. That's the conundrum that I'm talking about. We put a lot of effort into the browsers to understand ES6, and as everybody needs to transpile it because they want to support older browsers that should not exist any longer, like Internet Explorer, I work for Microsoft. We write this code that gets generated and that supports these old browsers. I'm not kidding. Internet Explorer 8 and 9 is retired. It should be on the field playing with other browsers and just going fishing or something. Don't write code for it. Don't pester it anymore. It's dead. Then we got feature testing, of course. Feature testing is an awesome thing because you just test if something works and then you give the browser the thing it does. And that's how I wrote my JavaScript for my whole life. Like, if navigator ambient light, then I can use the ambient light in my application. It's like jumping into a river after testing that there's no sharks in there and it's deep enough. It's probably a good idea. You can do it without it, but it's probably a better idea to put an if statement around things. There's feature tests.io by Kyle Simpson, and it's just a JavaScript library you can put in, and then you get a whole object saying what the browser can do right now. And it caches it for like a week in local storage as well, so it doesn't run the JavaScript call every single time and the test every single time. It's pretty sweet. It's also a good way to take that library apart and do your own tests for only the things in ES6 that you want to use. Like, how do you test if arrow functions are supported or not? The problem with feature testing is that it's an extra step that might be costly on top before your application runs. But if you think about applications, then it's just a part of your bootstrapping process and it shouldn't be that costly at all. We can only do it client-side. That's the real problem, because server-side we don't know what browser is going to be in use because it's only our server or Phantom.js or other headless browsers that might come. We can get false positives. Experimental features might be implemented in a rudimentary fashion. So it says like Opera was really good at that at time. Like, yeah, we got that API, but we don't have any of the methods. So you're like, great. So okay, I test for the main object and that was not good enough. I had to look through all the messages as well. And we have to keep our feature tests up to date and extend them as needed. Support for one feature does not mean support for another. To a degree. I find this a bit of a harsh thing. I love the cutting the mustard object that people do at BBC in England, where they do like navigator. Well, they test for three things that modern browsers do, and then put the modern code only in that browser. Modern doesn't exist, but we keep throwing that around. But at times you have to be pragmatic and say, okay, I don't want to test for every single thing that I'm testing against. Yeah, I'm writing an article about this, so I'm going to stop now. You can use an abstraction, a framework or library that has similar features. There were a lot of them. TypeScript is by Microsoft and is used in Angular 2 right now. There was CoffeeScript, that's not getting much love anymore right now. There's all kind of like, there was SaneScript, SoundScript, whatever, use the force script. People will come up with a new one every week. And all of these things are JavaScript that transpile into JavaScript in JavaScript. That was my shower head in my old flat for like 6 years. That's how lazy I am. But abstractions are pretty amazing because they allow us to do things now that in the future will be in the browser. Of course, there's problems with abstractions. They make us dependent on that abstraction. The amount of people that had done job interviews with me, and I tried to hire them to work on Firefox as JavaScript developers, and they only knew jQuery. They're like, did you think the browser was written in jQuery? No, why are you here? You know, it's we become dependent on that, and we know more of the syntax of new things rather than the language itself. We can't control possible version clashes in the abstraction layer, like Angular 1, Angular 2, problem right now, but people will have to deal with it. Maintainers need to know the abstractions instead of the standard of ES6. So if you rely on an abstraction, hiring becomes harder because you have to either train people up on that abstraction or you have to only hire that use that abstraction, which makes them more expensive people because they already are in the know. That's the ES6 conundrum. We can't use it safely in the wild because the browser support is not good across all browsers. And it's getting better, and it's getting, I probably will take that out soon because it's really fastly approaching the way where we can use it across browsers. We can use TypeScript or transpile it, we can feature test for it, but we can kind of complex very quickly. Browsers that support it will not get any ES6 that way. And that's the problem. Like we cannot test in our engines how well our ES6 performs in the wild if people don't give us ES6. We can use it internally for all extensions and like developer tools. They're all written in ES6 by now because it doesn't make sense to go in an older browser when you define the environment. The performance is bad right now, but that's a normal thing because we made the language much more complex than it was before. So we did a lot of new things in the language, so the performance is bad. So for making it better, we need you to use it in the browser. As you want to support older browsers and all browsers don't support it, you cannot use it. See where it's going with that conundrum. Yeah, so we really need people to run ES6, but we don't know how yet. There's a great ES6 performance test as well, which is to KB Decker GitHub IO 6-speed. This is very interesting because the things where ES6 is faster than anything else is the things that only ES6 has. Everything else is slower at the moment, which is kind of depressing, but as I said, it's not surprising seeing that the technology is much more complex than it was before. So you can help us make this better, and that's why I'm calling out to you, not personally, but in general, that people should get up to speed on this. There's no shortage of ES6 bubble right now. A lot of people, when I talked earlier, when I came into the room, like, oh my god, ES6 is going to show all the syntax and all the cool things, how much shorter the code is right now. Every week there's a new thing where people show you how ES6 will solve all of your problems. It will, but I'm getting tired of just hearing the technicality of it. What I really want to see is what benefit your applications have from it and how you can do it. So if you have an environment that you can control, please do it. So be active. If you use JavaScript in an environment you control, please use ES6 and feedback your experience to the browser creators and the standards bodies, because we need you to use it. There's no sense in a standard that people don't use. And looking through the W3C website, there's lots of them that people never used. And that are quite interesting. I spent 2 months writing XSLFO to generate PDF one time in my life, and then I created a LaTeX script and didn't tell anybody instead. Help ES6 by looking at the unit tests. The unit tests are available on GitHub by the ECMAScript consortium, and they are the ones that the browsers use to test against. So if you find a bug in those unit tests, or if you find a thing that is, yes, it tests it, but the performance would be awful, take a look at those unit tests, and then you can help the ES6 adaptation. The slides are on SlideShare as well, so if you want to have the links, and there's going to be a blog post as well, so no need for blurry pictures. You can learn and fix issues with a great website called ES6Katers.org, whatever a Kater is. It's a daily test where you can see one feature of ES6 to play with. And that's pretty awesome, because it makes a playful thing rather than seeing the big specification that nobody wants to read. You can see the Babel.js docs and try it out in the browser. So if you go to Babel.js, you have the documentation directly in the page here, and you got the online REPL thing where you can type your ES6 and it turns it into ES5, so you can see your code running immediately in the browser. There's also MDN, of course, is always the best resource for everything. They got a massive ES6 repository in there as well. They were the first ones to publish that one. And Nicolas Belvacqua, an Argentinian developer who's really, really nice as well, did this 350 bullet points. He wrote, like, every day he wrote an ES6 post in the last month or so, and now he put them all together into 350 bullet points where you learn all the syntax, you know what everything means, you get a quick introduction of what to use what for, and so on and so forth. There's a great book by Axel Rauschmeier, Exploring ES6, which is free to read online, or it's like $20 or $30 to buy the digital copy. I'm one of the reviewers at the moment, so it's on LeanPub, so every day there's a new build and I download it again. And it's a beautiful book because it's not one of those like, oh, and here's the future. It just shows you how ES6 came to be and shows the discussions around different things as well. So a lot of times we couldn't, for example, implement parts of ES6 because it clashed with what people used on the web. There was, for example, array contains was a functionality in ES6, but we couldn't call it array contains because MooTools in an 8-year-old version had an array contains in it, and putting it in the browser would have broken all the websites based on MooTools, which we wouldn't think are many, but actually there were a lot of them. We sent the Bing crawler out to index the web. Bing is a search engine, you can Google for that. That indexed like 14 trillion pages or something like that, and we found many, many pages still relying on that MooTools thing. So we went back to the ECMAScript body and renamed it to array has or something like that instead of contains. And it's quite funny that like how broken old functionality makes us not put a new standard in the browser because we would clash with what's out there. So JavaScript in general had a bumpy ride, and there's many prejudices towards it. Like a lot of people are like, oh, it's just a toy language, I never want to understand it, I never want to do it. But I think it's just time to open your mind and learn how far it has come and what it can do for you, because it's been good to me, it's been good to other people, and it's good to have on your CV right now because everybody's looking for it. And ES6 means you will use it professionally rather than just do the copy and paste job that we did in the last 15 years. Now we have a language that can be taken serious and is used for serious things, so please write serious code rather than error-ridden code that we did in the last 15 years. That's all I have, so here's a hedgehog getting his belly rubbed, and I hope, if nothing else helped today, that made it worthwhile. Thank you.